Hi everybody, 𝗘𝗽𝗶𝘀 here. I'm an Agentic and OutSystems architect, and I bring you today the second episode of the Agentic Workbench series, and this time focused on how to handle data when operating with an agent. And the reason why I bring this episode is because I noticed that there is a lot of challenges around how to manage data and how to ensure that the agents can have a proper life cycle with a good cognitive load of information and to avoid those typical timeouts that sometimes we have when we give too much information. So today we are going to focus into know what really happens under the hood when we give data, when we give documents, when we give information to a model. And by having this knowledge, we will be able to better manage how to properly give the type of information in the correct timing so that we can better manage the cognitive load of an agent. So let's go and explore this topic today. You guys might be familiar with this image, and this is because I presented in the last video when I was telling about the difference between an AI agent and an AI model. And in this case, I wanted to show again the AI model just to revisit the way of how an AI model receives inputs and then he spits an output and iterates on that. So if you guys might remember, I gave the example that for an AI model that is basically the brain of the AI agent, when we give him a set of inputs, for example, the sky is, he calculates what is the next token, most likely token to fill in this sentence. So he calculates that blue is the most likely. Then we aggregate the blue into the rest of the list of tokens that composes the input, and we give it back again, and we iterate this until the model decides that the sentence is completed and can be given. So in this case, we would have the sky is blue and the sun is shining. So if you guys look into this concept, this means that we can only give to the AI model a number of tokens that he can handle, right? Because if the AI model is composed of a very complex set of neural networks, and if he has a limit of the number of tokens that he can give or can receive, this means that we need to correctly or we need to manage the information that we give so that we do not overload him with information, right? So if we look into a typical situation here, we found that the first iteration, we had the sky is, and this was the input tokens that we gave. And then we run one time the model, he gave blue. So in the second iteration, the blue is already considered an output token. And then after n iterations, we had the sky is blue and the sun is shining. So if we would consider that this AI model is very limited in terms of inputs and he could only handle 10 inputs, we might see that after the iteration 8, the model was really close to the limits of what he could operate. So the first thing you might notice is that first, the input tokens and the output tokens, they come together into the same list of total number of tokens. And the reason to do this is because you might remember that I said that whenever in an iteration we receive a value from the model, that value is added to the previous list and then reiterated again to the model. So this means that if we continue doing this progressively, the amount of tokens that will be necessary to give to the model will be the sum of the input tokens that we gave initially plus the output tokens that we did until the last iteration. So that's why in this case, the model finished in the shining and it finished in the correct position because it did not overload his memory or the inputs that he could handle. But this is a very important thing for you guys to realize, is that we cannot only give inputs to a certain AI model and expect him to handle all those tokens, because he will also need to reserve a space for the output tokens that he gives and to iterate. That's why, for example, nowadays it doesn't happen this so much in the new ChatGPT, because the new ChatGPT is composed of multi-step processes here. So it's not only a set of iterations, but it's a multi-step of agent calls, each one of them with different iterations. But in the old days, if you would go to ChatGPT, for example, 3 or 4 in the beginning, you would see that if you would give a very big prompt to the agent, he would reply to you with a very small amount of text, or he would take a lot of time doing that, and we will go on that after. But most likely he would give you a short answer. And the reason for that is because he did not have more space to handle the tokens, right? So he would simply reply very small. And the interesting thing here, and this is one of the reasons why I always insist in handling agents and models a bit like humans and the brain, is because this resembles a lot like a short memory. And it makes sense, right? If someone comes to you and completely overloads you with information, it will be very hard for you to have space in your head to give a very big answer. Also, probably you will throw the towel to the ground and you just say something short and that's it. So normally there needs to be this ratio between the amount of inputs of information that we give, so that we can also reserve space for the short memory of the model to also process the outputs that he wants to give. But we talked here about an interesting thing, that is the fact that sometimes when you guys would talk a lot to an agent, right, he would get slower and slower in the responses. And the reason for that is because in a very short explanation, he would run out of space to put more tokens. So how would he handle this? So let's see here. So the model just returned to us, the sky is blue and the sun is shining, right? And we want to continue the conversation with him. So after that, we write in the prompt, we say, how was it yesterday? If we want him to understand the context of this message, right? Because the only way for him to know what I mean by how was it yesterday is by checking the previous messages, right? So this means that he needs to have a sort of a memory of this conversation, right? So if we give him this full amount of information, for example, from the agent said the sky is blue and the sun is shining, right? This means that he would already have the amount of tokens that he can handle, they would already be almost filled, right? From the 10 spaces that he has here, 9 would already be filled by the sky is blue and the sun is shining. So this means that for him to handle the new tokens given, he needs to do some operation. And this operation is called truncation. And there are a lot of different strategies to do a truncation, but normally if we do not specify, the default behavior is to do a strategic truncation where he basically resumes the conversation so far. So what he does basically is that he picks the full memory or full amount of tokens that he handled so far, so the session of the conversation so far, and he runs a step before starting doing what we ask him to do, he runs a step where he summarizes the content of the conversation into a smaller content. So he does a sort of a resume. And there are also other types of truncation. For example, you can have a cut truncation strategy where you basically, the model basically cuts completely the historical messages before a certain moment. So he picks the full list. He cuts, for example, in half the older half is lost in the context. But the reason, or this is not so good, because indeed he starts losing context very fast. So the truncation strategy of summarizing is one of the best because it ensures that at least the most important things remain. But at the same time, there is a problem here, is that when he starts to do a lot of truncations, because the session is very big, he needs to start resuming even the important things. Because if everything starts to become important and the message is still very big, he needs to cut some important topic. So this means that he will forget something, he will lose some context, and most likely he will not give you the best answer. And again, this is how we work also. If we start being flooded with a lot of information, we stop losing the whole amount of context. If I tell you guys, hey, let me give you here a set of numbers, 3, 7, 35, 14, 127, and 2222, and the sun is really beautiful today, it's very hot here in the Netherlands, most likely, so far, if you guys try to remember what I said, you will not remember all the numbers. So in your brain, you will simply resume into something like, oh, he gave us a set of numbers, and then he told that the sun was shining, it was very hot in the Netherlands, right? So you also do this, or we also do this when we are dealing with data. So after truncation, something like this happens. So in this case, I'm summarizing a lot of things just for the example, but he decides to summarize that to continue the conversation of how was it yesterday. He just needs sun shining. How was it yesterday? And then after doing this truncation, it follows the normal iteration process as we saw before. So this is how an AI model handles the input tokens that come in, and how he ensures that even during a session that he needs to continuously having an historical list of messages, this is how he ensures that he can continue to operate. But again, remember guys that every time he needs to do a truncation, he needs time to do it. So we need to realize that if we give him a lot of information, and if we continue to give him a lot of information with the same session, he will need to always be doing these truncation steps, which take time. So yeah, now we know a bit how the inputs work. But in reality, what are the inputs, right? Because we see a lot of things in the Agent Workbench, right? We have instructions, we have grounding data, we have memory, we have the user messages. So what from these, what does it fall on input for an AI model? The simple answer is everything. So when we are creating system messages, those system messages will fall into the agent input. The instructions will also do the same thing, grounding data the same thing, and also memory and the user message. So all of these 5, they are in reality condensed into the set of inputs or tokens to give to an AI model. So this means that in reality, we are dividing them to help us differentiating the types or the different aggregation of information, but in reality they all fall more or less on the same way to an agent input. And this is really important because it means that the more you guys give information in one of these 5 types, the bigger the total of input tokens we will have. So the agent, again, will have less space to process the topic, or it's not so much now about the space, because as I said, the new agents that exist, Claude, ChatGPT, they already do a sort of multi-step and reasoning where they iterate more with agents, but nevertheless, the more information you give, the more time he will need to reasoning, the more time he will need to truncate and to do all those operations. So it takes more time replying. And we can see this. So if we go to our Survey Studio, we can realize this very easily, because if we check the agent task, right, we have here the different steps. We have the get grounding data, where we can put aggregates, we can put information coming from the database or other, but then we have here the step of building messages. And if we go here, you guys may notice that we only have one type of output, a message output, and then everything goes inside here. So first the system message is added, then the grounding data, or in this case grounding data first, then the system messages, then we load the memory, and we also put the previous messages from this session, then the user message. So we have here the 5 that I just talked. They are all put it in the same list of message and then giving to the user. So if we come here, we see that when we call the agent, we are giving this as a list of messages and not separate grounding data, instructions or others as we are operating before. So again, the way we divide these topics are more to help us organizing the data and the steps we want to give, but in the end they are very similar to when we give them to an agent. We can separate things saying, hey, this is the data that you should operate with, or this is the previous list of messages. So we can, of course, add a sort of a heading of each one of these types, but the agent will process this as inputs. So we have here the 5 types, right? And I can say that most of the times, the ones we need to be careful with are the grounding data and the memory. And the reason for that is because normally the system messages, the instructions, and the user message, they have quite a static size. Sometimes the user message can also be big, but that comes from the user side. But the system message and the instructions, normally they are static, or they are more static. They can have a bit of tweaks, but most of the times they are on a stable size. But normally is the grounding data and the memory that can grow up or can scale with time, and that we need to handle them properly. So how should we handle the data here? Let's pick here an example. So imagine that we are a salesperson and we need to do a meeting with a client because our company has some new products, and we need to talk with the client about this new set of products, right? So one of the things that you might consider in the day before when you are preparing the meeting is, what should I prepare and bring tomorrow, right? And let me give here a list of 4 examples for us to evaluate each one of them. So he might consider preparing main information about the client and its business. So probably knowing a bit about the client, what is his name, if he works for a long time in the company, so to know a bit of fun facts about the client so that he can create a rapport, something like that, and a bit also about the business. So what is the business of the client? What do they do? And also some fun facts that could be important from previous interactions, right? So we have this. We also can prepare and bring main information about the new products that we want to show. And here the main information talking about those products, the main specifications, their advantages, their costs, and so on, right? So main information, so to say. Then we can also prepare information about the products that we sold to the client in the past. So far, what did this client bought? And finally, we could also bring the current financial and payment situation of the client. So if in terms of invoices, if everything is up to date, if he paid everything, right? So these were 4 examples, right? And now let's analyze one by one, because let's do here a bit of simulation. Let's assume that you cannot bring any papers or laptop with you. You can only bring your memory. So here you need to decide what you should prepare so that you can bring to the meeting. So let's evaluate first. Main information about the client and its business. Yeah, we might consider, and I think we all agree that it's important for us to know, right? We cannot go to a client and not knowing his name, not knowing his business. So it's important that we prepare and memorize the information, main information about the client and the business. About the new products, that is the main reason we are doing this meeting, right? So it would be really strange if we would come to the meeting and the client would ask something about those products and we didn't know what he was talking about. So yes, it is important at least to know the main information about the new products. We are not asking you to know all the small details and small specifications of the product and to the very minimum list, but at least know the main information, the most important one. If the client wants to know a bit more details about a certain thing, you can always align with him to bring that information on another day. But now let's look in the information about the product sold to the client. Just notice that I'm not talking here about in the last 3 months or last week, or I'm not saying here about an aggregated information, like what are the top products that this client buys. I'm stating here that we need to memorize the information about the products sold to the client. So there is here a bit of a mixed feelings, right? Because it might be important for us to know a bit the overall situation of what he bought to us in the last year, months, or something like that. But we don't want to spend time memorizing the full list of products that the client bought to us, including the date, the product description, the quantity. We don't want to memorize that, or else it would be completely overkilling, right? So this means that, yes, we can prepare and memorize a bit of summarized information about the products we sold, but we should not put the whole information about the sales in our heads. So probably it would be interesting for us to know that this client, he uses generators from our company, and in the last months he bought a large set of filters, of air filters, fuel filters, transmission belts. So we might know on a summarized way what he uses, what products did he bought, but we don't need to do this really in detail. Again, if he asks that in that meeting, it's totally okay that we check that afterwards and then get back to him with that topic. So in this situation is a yes, but be careful, do not overload with information. And finally, the current financial payment situation of the client. And it's also a bit of the behind, but also with another step back, because this is not really a financial meeting, right? We want to present products. So yes, it might be important for us to know if this client has overdue payments, or something like that, but that is more for our relationship with the company and for us as salesmen, not for this meeting specifically, because we don't want to point fingers to the client when we are presenting new products, right? So in reality, there is no practicability for you to know this. You can know, yes, because we are humans and we know this for other purposes, but considering if we only would prepare ourselves to this meeting, it wouldn't make a lot of sense if we would memorize information related with financial situation of the client. So if we pick these 4 examples and how we human did this, you guys can extrapolate the same thing to an agent. Just notice that this example, we might not want to have an agent to prepare a meeting for a sales, but the methodology that I took here analyzing the information that he needs should be also applied when we are building an agent for a specific use case, right? So if to finalize here this lesson today, if we want to ensure a correct data handling when dealing with agents, there are here quite some steps that we should take care. One of them is we should use grounding data only for strict necessary data that the agent needs to process that request. As we saw before, we should not give all the information that he needs. We should give him in the grounding data just the minimum master data that he needs to process correctly a certain task. Second, if some more information might be necessary that we do not know if it will be necessary or not, we can give the agent a tool for him to call if he needs to fetch more information. For example, in this case, if the client really asked about some previous sales of a certain product, and if we want to give him that, and we could bring a laptop, right, we could just open the system and check in the system what were the previous sales, right? So in this case, the agent can do that using tool. So we can give to the agent a certain tool, for example, get products by client or by date that he could filter, and he could make sure that the result is still a small amount, but enough to give to the client. So you can always use tools to fetch data that it might be or not necessary. Third, if you want to give him full sets of documents that are big, so remember that the documents will be converted to tokens for him to use as inputs. So if you want to give him a full set of documents because you might want him to search across the document for specific contents, then it is better for you to use a search index system, like for example a RAG, because using a RAG, what happens is that he calls a certain index database about and queries about some content, and that index database gives back the parts of the document that has that content. So it saves a lot of space in the inputs of the agent. And fourth, don't use the memory as an infinite incremental resource. So if you get stuck, or if you stuck the memory in the same session ID and you always give that amount of data to an ongoing process, this will become bigger and bigger with time. So it becomes really hard to an agent to manage the previous amount of messages. So make sure when you are creating a more complex task with workflows that you do not overkill the amount of memory used to give to an agent. Maybe it's not necessary to give the full history, or maybe it is, but we should find a way to make sure that does not scale. And finally, one of the most important things, if you want your agent to be production ready, make sure you don't make the input data incremental with time. So make sure that if you do aggregates and you give data based on aggregates to the agent, make sure that those aggregates do not grow with time. Give him a max amount of records. Or for example, in the memory, make sure that you don't give an infinite amount of memory, that you only bring the last amount. So make sure that you protect the whole code so that with time and with more and more data being set in the database, that you don't get stuck with the processment and the amount of information you give to the agent. So in this way, don't make the input data incremental with time. So this concludes the second episode of the Agent Workbench series, this one related with how to handle data when operating with agents. Of course, feel free to drop some comments or to give me feedback about this. Feel also free to share some more specific use cases that we can handle them or we can check them together. Of course, this is a very important topic, so to ensure that we can deliver agents that are production ready to our clients and that they can remain stable over time. Have a great day.